Hi, this is chapter 9 starting with first order linear systems. It's a neat way to solve systems of differential equations. So let's get started. First order linear systems. This is a lengthy way to write, so I have it all boxed for you with colors as you could see. dx1 dt equals a11t x1t plus a12t x2t all the way to a1n xn plus b1t. Same thing goes all the way down to dxn all the way down to bn, and this is what we have, first order linear systems. Why they call it first order? Because it involves first degree of derivatives only. There is no second derivatives. I have everything written right here, so I'll show you in just a second. The red parts right here, a sub ij, and the green parts right here, b sub it, are specified functions on an interval I. If b1 and b2 all the way to bn, all of them equal to 0, that means they're not there, the system is called homogeneous. Otherwise, it's called non-homogeneous. Remarks. The highest derivative is first order, as you could see. There is no second derivative or third derivative. There is exactly one equation involving the derivative of each separate unknown function. So dx1 dt, there is only one equation that has it. The first derivative of x2 with respect to t, there is only one equation that has it. That's what this here says. The terms that appear on the right hand side of the equations do not involve any derivatives and are linear in the unknown functions x1 all the way to xn. There is no derivatives right here, and linear in x1, x2, xn. There is no second degree or third degree of x's right here. We will usually denote dxi dt by just writing x sub I prime. Here's an example. This is a non-homogeneous first order linear system. x1 prime, x2 prime, that's dx1 dt, and that's dx2 dt. This is b1, this is b2. Now, if in case these are gone, we will call it homogeneous. The associated homogeneous system is same except the sine and cosine part. This is just like to show you how do they look like as non-homogeneous and homogeneous. Here's an example. Verify, this is just like to verify, which is mainly like a discussion. There is nothing to solve here. Verify that this x1 and x2 together is a solution to the linear system of differential equations x1 prime equals and x2 prime equals. Let's start with the first one, x1. To start with x1 prime equals x1 minus 8x2, we could work separately on left and right and see if it works. How do you get x1 prime? Well, I have x1, I'm just gonna take its derivative. That's my left hand side. So take the derivative of x1, right there, step by step, and we're done. Now on the right hand side, I'm going to take x1, which is up here, take x2 multiplied by 8, that's x2 multiplied by 8, subtract, see if I end up with the same answer that we got from the left hand side. I'm skipping the algebra steps. You could pause and look at it, trying to save you some time. And as you can see, this is just like a general example. There's nothing much in it. So it does simplify to the same thing, meaning that x1 prime equals x1 minus 8x1 are equal, so x1 prime is satisfied by the given functions for all t that belongs from negative infinity to infinity. In the same way, we could just verify that it works for x2 prime. Let's see a different example. Now here we're solving, not verifying. And this is a new technique. It's so neat and simple at the same time, and I'm sure that you're gonna like it. Let us move all the terms to the left hand side and keep them organized. x1 terms first, then x2 terms next. Move this to the left, move this to the left, 2x1 to the left, minus 2x2 to the left, and have it 0 on the right hand side, just like algebra. You know, in algebra, when we solve elimination, substitution, we like pretty much everything organized, especially in elimination method. We like them lined up. So now I have the following. This moved to the left with a minus sign now. This moved to the left with a minus sign, and so on. As you can see, I have x1s first, then x2, x1 first, then x2s next to each other. You know, if you want to move this here and this here, I don't want them to be like around. It's good to have them next to each other. Now here's something that we used earlier but we didn't take much advantage of. This is x1 prime minus x1. As in operator form, we could rewrite this as d times. Let's take a look and see it instead of confusing you. We'll just slow down and see it. In operator form, as you could see, this right here is d times x1, which is x1 prime, minus 1 times x1, which is minus x1. These two will be written in operator form again, same style. So we go d minus 2 times x2 right there. Okay, that's kind of neat. Now you could solve and simplify and cancel x1. I'm gonna go and cancel this one for one reason. I have a minus sign and I have a plus sign, so the idea of opposites already there. I just need to have the same amounts to cancel them and call it elimination method. This 2 has to be here. This d minus 2 has to be here to have them equal, opposite but same amounts. So I'm gonna multiply the first equation by d minus 2, multiply the second one because I'm missing the 2 times 2. This is more to help you understand this part right here. So let's do what I just told you about. Multiply this by d minus 2 and this by 2. Right there. Now take it in distributive property and take it in right here also, the 2 inside. And once you do that, I have the following. The plan is to have this amount the same with the opposite sign, so I could cancel them, and that's why I brought d plus 2, and that's why I brought in the 2 right here. These cancels. This way we could focus on x1 and solve for x1. Once you add these guys, I'm showing you the steps step by step. This is what I have. Instead of reading it, you could see it clearly. Doing the algebra simplifying here, combining the x1 terms and rearranging, we will have the following. I multiply these two, distributive. I could see it from here, minus 2x1 and a minus 4x1. That's gonna give me a total of minus 6x1. Alright? That doesn't get affected, it's the same. D square x1, it's right there. Using the auxiliary function p of r, that acts like r squared plus r minus 6, factors to r plus 3 and r minus 2. That gives me a minus 3 and a positive 2. So the general solution for x1 of t, that's for x1, will be c1 e to the power negative 3t and c2 e to the power 2t. Now we found x1, we still need to go back somehow and find x2. Looking around, I would say the best one is this one here. You don't have to, but that's x2 right there. Alright, so let's take it to the second slide and move from there. Now it's on the second slide. As you can see, I have x1. To solve for x2, we will use equation number 1. What do I mean by equation number 1? The following. Let me go back and show you. This is number 1, which is the same one right here. D minus 1 times x1 minus or subtract 2x2. That's the same one. So I'm using this one so I could focus on x2 and solve for it. I have x1. Gonna put it right there. Apply the derivative and apply a minus 1 to it. Do the algebra steps and end up with x2 by itself. Okay, let's go back. Since my focus on x2, I'm moving it to the right side. I have it positive now. Gonna divide both sides by 2, which means x2 equals half d minus 1 x1, or differently, the other way around, x2 equals half times d minus 1 x1. Now, taking x1 inside, that's dx1 minus x1. That's the derivative of x1, derivative of this right here. Okay, that's what dx1 means. So we apply the derivative to x1 and we subtract x1. Once we finish, multiply by half, and that gives you x2. I'm skipping the algebra steps. You could verify it. Take the minus inside, bring the minus 3 down, bring the 2 down for derivatives, and simplify. This is what I have. So this is the final version for x2. So what's the solution now? We have x1, we have x2, and here we go. So x1 equal and x2 equal. Done with this problem. Kind of neat, right? Using algebra to solve with elimination. Also, on top of that, the operator, or what you call the derivative operator, d that we applied. Here's another example. This is with the initial conditions, so hopefully we won't forget to plug them in and find C1s and C2s. This is my system, and we're trying to solve. This is a new technique. We had that long time ago in a previous section, but chapter 9 starts with this kind of technique, which is kind of neat. From the previous problem, we had the solution for this, and that was given to me right here. Let's just plug in the numbers. x1 of 0 equals 1. x2 of 0 equals 0. Just plug in 0 wherever you can, wherever t is. E to the power 0 is 1. That will not take our time to solve and simplify. That should end up 1. We want it to end up 1. C1 times 1 plus C2 times 1, and so on. I have C1 plus C2 equals 1. And I have minus 2C1 plus half C2 equals 0. Just algebra steps. We'll get C1 equals 1/5 and C2 equals 4/5. Putting this back here, replacing C1 and C2 with these numbers, I get the solution to the initial value problem. And it's right there. Alright, not too bad for this section. Just algebra steps with the technique of the derivative operator and the elimination method. Thank you for watching. I hope that it was helpful. As usual, hit the like button if you like it, subscribe, comment below, and if you like this video, there is more. This is my 5th one tonight, and I'm still going. It's actually 5:47 a.m. now, and I haven't slept yet. I'm still recording another video at least after this. So until next time, peace. JaberTime.